Hello, welcome here guys. The video you're about to see is taken from a full course you can find on academy.inco.com. So if you're looking for more context, more lectures, more videos, more explanations, you can find it for sure there. And now you can enjoy the video. In this lecture, I've been explaining Ethereum blockchain on the base level. In this lecture, will continue in a similar fashion. This lecture will be again AI lecture. So if you have enough information about Ethereum blockchain, you can skip this one and you can continue with the next lecture. Okay, so without any further waiting, let's start with the explanation or recapitulations of differences between a banking system and Ethereum blockchain system. I was talking in previous lecture mainly from the perspective of the transactions. Of course, there is much more into Ethereum blockchain and also much more into the banking system, not just the banking transactions, of course. Okay, but let's mark here some biggest differences so you have it on the paper. Okay, so differences between the banking system and Ethereum blockchain. First, in the terms of centralization, in the case of a banking system, banks are centralized, usually owned by companies or owned by governments, right? So yeah, they are definitely centralized systems. They are running the centralized ledger. So the ledger of all of the transactions, they are centralized. So let's mark here centralized. In the case of the banks, they are centralized. Comparing with the blockchains, in this case, in an Ethereum blockchain, Ethereum is definitely decentralized, and it's running thanks to the connections of many nodes. Okay, so we have a centralizations and the decentralizations. Also, Ethereum is not a company, it's the open source project that's running by Ethereum Foundation. It's not running by Ethereum Foundation, but Ethereum Foundation is working also on Ethereum blockchain. Okay, but this is actually for the resources. After the lecture, I will give you the resources to read about Ethereum Foundation. Okay, so centralization and decentralization. Okay, what about the other differences? I was mentioning in the previous lecture that when you want to open a bank account, you need to provide some private details. Of course, you need to provide your name, your address, and so on your details. Okay, so you need to provide your personal information, okay? Personal info if you want to open your bank account. You don't need to do it in the case of the blockchains. No personal information is here. Okay, you just simply will create an account and that's it. So no personal informations. Okay, there are also other differences about the fees in the banks. Usually when you have an account, you need to pay fees. So you need to pay here fees and this stuff, and here you don't have any fees. All right. Okay, in the banks, you are keeping currencies issued by states, so dollars, euros, so on. These currencies are inflationary. They're actually inflationary. The digital currencies are, not all of them, but usually the digital currencies are non-inflationary. They are in some cases they are de-inflationary. Okay, because dollars can inflate and they can lose the value over time. In the case of a Bitcoins and Ethereum, and actually in the case of a Bitcoin, when you have a limited amount of the Bitcoins, that will not happen, that it will be losing the value. On the other hand, it will be gaining the value. But about this stuff, I don't want to talk. I just would like to talk about the development stuff. Okay, but these are some of the main differences. We'll be talking about the other as we'll go through the lectures. Okay, so if we have this recapitulated nicely, we can start talking about the development on the Ethereum blockchain. Also, to not forget, I would like to mention here also these resources. I will include them in the links of this lecture. So here is about the Ethereum Foundation to read something. Okay, just scroll around here, maybe ask me questions in the Q&A section. And and so on. I really like the core values of the Ethereum ecosystem here. I would read about them. And also, as I mentioned, Ethereum is open source project, so anybody can make contributions, and you can make improvement proposals called AIPs. Okay, you can also read about them here, just as the off topic of this lecture. Okay, so now let's continue. What is the Ethereum also capable of? I don't want to talk only about the transactions of the money. Okay, so let me go back to our drawing board and I'll draw here something more. Okay, I'll get here a new note. Okay, and we'll be talking about some stuff on Ethereum. So first of all, on Ethereum, we will call it Ethereum State, this database I was talking about where all of the accounts are stored and the balances of the accounts are stored. Okay, so we'll call it Ethereum State. Okay, let me mark it somewhere here. Okay, so here in the corner, Ethereum State. Okay, Ethereum State, where we are keeping all of the accounts, also all the balances of the account and so on. Okay, Ethereum State. Every account on the Ethereum has a specific format. It's the 20-byte number. Okay, usually noted as the hexadecimal number. So these numbers start, if you have an account on the Ethereum, you usually have an address like this, 0x, some hexadecimal number. So this 0x saying it's a hexadecimal number, and 20, it has a 20 bytes. So let's say 1, 2, 0, 8, and you have a 40 of this number because this is 1 byte. Okay, it's 1 byte, so you have a 20 of this. Okay, so this is the address. Okay, this can be, for example, Bob address, or it can be my address. Okay, so let's say this is a Bob address, this is my address, let's say 34B0, and again, you have a 40 of this character, so 20 byte number. I'll mark here is a 20 byte number, is a unique address, 20 byte. Okay, so this kept on Ethereum State for every account. These links to a structure which will keep your balance, right? So as I was mentioning, I'll make it a little bit zoom out. There you have your account balance, right? So let me draw it. I'm still not very used to drawing, but let me try it. Okay, so every account has some balance. That's very important to know. Balance, and is saying how much money basically you have on your account. So balance, let's say 10 ETH. Okay. There is also a nonce number. And about nonce number, I would like to want to talk later. Let's say nonce number 3. This basically means how many transactions we have made from our account, and I will be saying why it is important later. That's not important right now. Just to know now is that when we are creating account on Ethereum, we have this address, and there we can keep a balance. For example, if we bought 10 Ethereum, we will be keeping on our Ethereum account 10 Ethereum, not 10 Ethereum, but 10 ETH. Okay, so we'll have a 10 ETH. Okay, that's let's say Bob's account, and we have a Philip account, and then we have a different balance and a different nonce, of course. All right, so that's in the terms of the accounts, and this is called when you have only your account only balance and nonce. That's a usual Ethereum account. This is called also externally owned account. So this you can say this is an externally owned account. I will say it here. Externally owned account. Okay. You can write it if you're writing it somewhere externally. Externally owned account. Okay, so that's an externally owned account. All right, there is also other type of the account, and that will be the main. This will be the main part of the course we'll be talking about. But before we'll take a look on the other type of the account, please let's go to your browser and let's search here for Etherscan. Etherscan. On Etherscan, I think it's .io, I'm not sure. Yeah, Etherscan.io, you can check all of the blocks that have been mined. I was talking about the blocks containing transactions which will alter the Ethereum state. Okay, you can notice here every mined block, and also the transactions in this block. So let's say here you have a block, this one, and you have a 275 transactions here. You can select any transactions here you want. And focus now on the methods where the method is transferred. This means that this has been transferring only some Ether from account to account. Let's say this one here. You can see here, this went from this address. As I told you, this is a 40 hexadecimal, so 20 byte address on the Ethereum, and this user of this address was sending some Ether to this address, so these two. By the way, we'll be talking about all of these fields later. For now, just important for us from, to, and the values. So the user here was transferring 0.0 Ether, so in the value of $64. It's currently 0.02 Ether. If you want, we can also click this address here on the from, and this will note me here all the transactions that this user has been sending. And you can see also this user has a balance, as I mentioned. So every account has a balance, and this user currently have 0.3 Ether, and all the transactions he or she has made. So you can see this, it's open. I can select any address and I can search all the transactions user has been making. Of course, I don't know about any personal information about the user. I don't know who is a user. Okay, but I can still see here what's happening on the blockchain. So that's a very interesting thing. Okay, so I'm encouraging you to maybe just search here through the Etherscan, but as I was mentioning here, there's a simple transactions from this address. We will be also creating our own addresses. We'll have a similar format, this 20 byte number. Okay, from, to, and Ether sent. Okay, and there is an externally owned account. Okay, so but the main part of the course will be working on different type of the account. We'll be working on an account where we'll be storing not just the balance and the nonce, but we'll be storing also some code, because you can execute a code, you can create a programs that will be run on Ethereum blockchain, and this will be interesting part of the course. So this program will also contain an address. So we'll have the same as these addresses here. We'll have an address for this program. Okay, so 0x, let's say 112C, and again 20 bytes, so 40 of these characters. And this will be different type of the account. This will be different type of accounts. It will be not externally owned account, but these accounts that contains code, some program, are also referred as the contracts, smart contracts. This is a contract. And the contracts don't have just the balance. They have balance as well. They have also nonce. But they have also something else. They have a balance nonce. Balance, because a contract can also keep ETH. So we will have some ETH, let's say 1 ETH. All right, they can keep nonce. How many transactions has been made? Say 2. But there is an interesting part that they have a storage hash property, storage hash, and also code hash. And these are pointers to different structures on the Ethereum blockchain. Storage hash is pointing to the storage, because we can store some data in the contract, in this program that will be running on Ethereum blockchain. So we can have here some kind of a storage. We'll be talking about the storage later. So this will be storage. We'll be talking also about how the values are stored in the storage and so on, but this will be some storage of data. But a code hash is interesting one. Code hash contains a bytecode. This will be our application. We will be writing bytecode. Okay, it will be not, of course, not applications as we are writing in our coding editors, but this will be already compiled applications. So it will contain some hexadecimal bytecode. Okay, so this will be the bytecode. This is a sequence of hexadecimal symbols. Okay, so this will be some 4060 and so on bytecode. So yeah, guys, so that's the difference. That's some basics about externally owned accounts and contracts. Okay, so And just to continue with this, we'll be writing these contracts. I will mark it here, actually. I will mark it here. We'll be writing these contracts in Solidity programming language. Solidity programming language. Solidity is an object-oriented language. So this is a normal object-oriented programming language. So OOP is inspired by C++. By the JavaScript syntax is very similar to JavaScript one. Actually, it also contains types. It has a types, and also what I want to say is it's has curly bracket syntax. That's what I want to say, curly bracket syntax. So the function body we will write inside of the curly brackets, and also we are writing semicolons, as you will see later. Okay, so we will be writing our smart contracts is in Solidity, which is very similar to JavaScript. Let's say we'll be creating the smart contracts. You can have any programs you want that will be running on the blockchain. Let's say you will have application called funds. So user can send some funds, and you will take care of the funds of your clients. You can create also banking application. You can create voting application, any applications you want. By the way, this extension Sol is denoting that this is Solidity application. When you would like to deploy application on the blockchain, it has to be in the bytecode format. Because the Solidity is a high order programming language, we need to compile it into the lower code, so in the bytecode, but you will see all of this later. For now, you can know that this will be compiled into bytecode and stored on the blockchain. Okay, so compiled in a bytecode. Okay, and this will be stored on the blockchain. So this will be this network of the nodes on the blockchain, right? So all of this is connected. These are just computers running this software. All right. Okay, so this will be blockchain, right? So this is a blockchain. Ethereum. This is Ethereum. I don't need to talk about this as a blockchain. I can talk about this as an Ethereum ecosystem or Ethereum platform. So now when you want to communicate with accounts or with the smart contracts, everything is starting with the transactions to the blockchain. So you will send the transactions to the blockchain. Let's say Bob will send the transaction. We'll say to this address here of the smart contract, so transaction to 0x11 to C, and you can interact with the code in this on this address. So you can say, I would like to add some funds. So you will call the function, as you will later see. You will call the function. You would like to add some funds. So let's say I would like add to Ethereum. So you will send this transaction, and these transactions will go to Ethereum blockchain. Again, it has to be mined. It will be added to the mempool, and in the end, it will find its way to smart contract code, and it will be executed. It will be executed in the bytecode. And since this is just a transaction to send some ETH, the storage, the balance of contract will be updated. Okay. So this will be not 1, but this will be 3 Ethereum. ETH. Okay, I'm keeping saying Ethereum, but if I say Ethereum, I mean ETH, because that's the digital currency, ETH or Ether. Okay, so that's just a really high overview. What I would like for you to take from this is that we have two types of accounts: externally owned, as that's a basically normal account I would create if I would like to keep some Ether on my account, or you have these contract addresses where you can keep also code. Normal software application as the JavaScript application, but this will be Solidity application. Solidity application basically can be any application, keep the funds of the user, banking application, or marketplace, whatever you want. This will be compiled into bytecode and stored on the blockchain. When the users on the blockchain want to interact with your smart contract, with your application, they can send the transactions with the address. Recipient will be the address of the contract, and they will send some ETH to it, or they will call some function in the bytecode. But about this, guys, later. Okay, guys. So that's should be it, and I think it would be about the time to to start coding, so you have a better understanding of Ethereum. Again, if you have any questions, these topics can be a little bit overwhelming from the beginning, but we will go gradually. Gradually, I will be repeating all the topics I have been talking previously about. So I will be repeating this stuff, and I will be adding little bit, and I will be making some quizzes for you. For reading, as I mentioned, about Ethereum Foundation, you can check the Etherscan, and also here is the illustrated Ethereum. Okay, so here are some stuff, but I'll be talking about this also. All right, guys. So that's gonna be it from this lecture. Let's see you in the next one. Cheers.